So I'm going to get on to how you find the domain and range of anything easy and quickly. So you ready? Okay, we'll go to the domain of y equals x minus 3 squared plus 5. So the first thing you need to notice is for domain we're only worried about this part. So this part goes down to here, and we know x minus 3 is something we're putting into a square. What can we put into a square? We can put anything into a square. So x minus 3 can be anything. It can be negative, it can be 0, it can be positive, it can be anything. So domain is all real numbers. Now we'll look at the range. Now the range is something squared plus 5. So we know something squared is always greater or equal to 0. Now we're looking at this whole thing. Okay? So this, if this point is always greater or equal to 0, and then we add 5 to it, the range is always greater or equal to 5. Or y is always greater or equal to 5. Which we can also write as 5 to infinity, including. Okay? So we can apply this technique to the next question as well. If we have y equals square root of 2x plus 5 plus 7, what's the domain? First we know that whatever we square root, we have to square root a positive number or 0, okay? Or whatever has to be greater or equal to 0. So we know that 2x plus 5 is greater or equal to 0, which means 2x is greater or equal to minus 5, or x is greater or equal to minus 5 on 2, because we take the 2 over. So our domain is x greater or equal to minus 5 on 2. Or we can write it as 5 on 2 to infinity. See that? I'm going to rub this out quickly because we're short on time. Time is so precious. Okay. Now how do we find the range? Well, we know a square root, this entire thing, is always greater, a square root is always greater or equal to 0. If this is always greater or equal to 0, then we add 7 to it. This thing is always greater or equal to 7. So our range, I'm just going to start writing in straight away like this, is 7 greater or equal to 7, which means 7 to infinity. Okay, so we'll look for the next one. Domain. What do we know about this? We know we can't divide by 0. So we know x minus x plus 4, because we cannot have this. That's a bad situation. So we know x minus x plus 4 cannot equal 0. So we take the x over, x cannot equal 4. Makes sense? Domain is all real numbers except 4. Easy. Okay, range. Okay, we look at this. We have 1 on something, blah. And we look at that. That cannot equal 0. Okay? So if this cannot equal 0, and then we add 5 to it, this entire thing cannot equal 5. Our range is all real numbers except 5. Because I'm just going to write it again. Y cannot equal 5. Just to be very clear, I'm going to write here y is greater or equal to 7. That's a much better way to do it. I'm going to start doing that for the other questions. Next one. If y equals 10 to the 2x minus 3 plus 7, what do we know? Well, it's 10 to this number, okay? And this number can be anything. So we know 2x minus 3 is anything. So what's our domain? Well, if 2x minus 3 can be anything, x can be anything. Our domain is all real numbers. Now, we have 10 to the blah, and we know 10 to the blah is always greater than 0. How do we remember that? Can 10 to the blah equal 0? No. 10 to the 0 gives us 1. 10 to the 0, right up here, 10 to the 0 equals 1. Okay? 10 to the negative number is 1 on something. 10 to the blah will never equal 0. It will never be negative, it's always greater than 0. So, if this thing is greater or equal to 0, then this thing plus 7 is greater or equal to 7. So if this thing is greater than 0, then this thing plus 7 is greater than 7. So y is greater than 7. Notice the not including bracket. Okay, this one. Now, log of something. We have log of something, and we know this something is always greater than 0. So 2x minus 5 is greater than 0. So I'm going to take the 5 over, take the 2 over. X is greater than 5 on 2. So our domain Easy. 5 on 2 to infinity. And our range, well, log of something can give us anything. If I can't remember that, so I got log of something. Log 10 of blah. What can that equal? Question mark. Well, if I power both sides, it becomes 10 to the question mark, and blah equals 10 to the question mark. That may confuse you, but otherwise you can just remember that it's that you can get anything out of log. So if this thing can be anything, then y can be anything. Y equals real numbers. Range is all real numbers. Yes, finally, the domain, we know for sine, just keeps on going, so we're not worried about that. But the peak and the minimum, that's pretty important. So we know this thing, sine of something, is always, it's in between -1 and 1. So 2 sine of something is always in between 2, -2, and 2. How do I write this? 2 sine something is in between -2 and 2. So we add 5 to that, to this thing, and that becomes -2 plus 5 is, I messed that up a little bit. Wait, so the main is all real numbers, unless they tell us something. Our range, unless they tell us otherwise, our range is, if it was just 2 sine something, it'd be between -2 to 2. But if we add 5, it's -2 plus 5. Our range is from 3. -2 plus 5 is to y, and 2 plus 5 is less than or equal to 7. I'll explain that more clearly in sine and cos. Finally, this one, well, we know that the domain is anything except when cos 2x equals 0. Because remember, tan is sine 2x, or sine x on cos x, but here it's 2x, so sine 2x on cos 2x, and we can't divide by 0. So when does 2x equal 0? When does cos 2x equal 0? I'll explain it to you later, but that happens when cos 2x equals pi on 2, so x equals pi on 4. So we can't have that. So our domain is real numbers except pi on 4, and our range is real numbers. But I just want to make the point that these two are a bit more complicated than domain and range. It doesn't work in the usual way, but everything else should be very clear. Okay? So good luck with that. You can try a few practice questions now. Cheers.